Welcome to a deep dive into the world of Azure Functions interview questions and answers. Whether you're an aspiring Azure developer or an interviewer seeking to assess top talent, this comprehensive guide is your key to mastering the art of Azure Functions interviews. Get ready to unravel the intricacies of Azure Functions, gain expert insights, and confidently tackle even the most challenging questions. Let's embark on a journey to unlock the secrets of success in Azure Functions interviews. What is Azure Functions? Azure Functions is a serverless compute service provided by Microsoft Azure, allowing developers to run event-triggered code without provisioning or managing servers. What are the key features of Azure Functions? Event-driven, executes in response to various events. Serverless, no server provisioning or management required. Scalable, automatically scales based on demand. Pay-per-use, build based on the number of executions and resource consumption. Integrated, easily integrates with Azure services and third-party APIs. Explain triggers and bindings in Azure Functions. Triggers, events or conditions that start the execution of a function, such as an HTTP request, timer, or new message in a queue. Bindings, connectors that define input and output for a function, making it easier to integrate with other Azure services and external resources. What are the different types of triggers in Azure Functions? HTTP trigger executes the function in response to an HTTP request. Timer trigger executes the function on a predefined schedule. Azure Cosmos DB trigger executes on new or updated documents in a Cosmos DB. Blob trigger executes when a new blob is created or modified in Azure storage. How can you secure an Azure function? Use Azure Active Directory AAD authentication for HTTP triggers. Set up API keys for function access control. Implement role-based access control, RBC, using Azure AD for function apps. What are the deployment options for Azure Functions? Azure Portal, directly deploy and manage functions through the Azure Portal. Azure DevOps, utilize continuous integration / continuous deployment, CI/CD pipelines. Azure CLI, deploy using Azure Command Line Interface CLI. Visual Studio Code, deploy using Azure Functions extension and VS Code. ARM templates, define and deploy using Azure Resource Manager, ARM templates. Explain durable functions in Azure. Durable functions is an extension for Azure Functions that enables the creation of stateful and orchestrator-based workflows using a set of extension methods. It facilitates long-running and stateful operations by managing the state and lifetime of functions, enabling complex coordination patterns. What are deployment slots in Azure Functions? Deployment slots are live apps with their own hostnames, allowing you to deploy different versions of your function app and swap them with the production slot seamlessly. This is useful for performing A/B testing, staged deployments, and rollback scenarios. Describe the retry policies available in Azure Functions. Exponential backoff automatically increases the delay between retries in case of transient failures. Fixed delay retries with a fixed delay between each retry attempt. No retry, no automatic retries. How can you achieve function chaining in Azure Functions? Use output bindings. The output of one function can be used as an input to another function by using output bindings. Use durable functions. Orchestrate a sequence of functions using Durable Functions Orchestrator. What are the scaling options available for Azure Functions? Azure Functions can scale automatically based on demand. It offers two scaling options. Vertical scaling, increasing the allocated resources, CPU, memory, to a single instance of a function. Horizontal scaling, adding more function instances to handle increased load. Explain the difference between consumption plan and premium plan for Azure Functions. Consumption plan, build based on the number of executions and resource consumption. Ideal for sporadic workloads with variable traffic. Premium plan, offers more control over the underlying infrastructure, reserved instances, and virtual network integration. Suitable for enterprise-level, mission-critical applications. How can you configure environment variables in Azure Functions? Environment variables can be configured in the Azure Functions using application settings in the Azure portal. These settings can be accessed in the function code using environment.getEnvironment variable in C# or os.environ in Python. What is the maximum execution timeout for an Azure function? The maximum execution timeout for an Azure function in the consumption plan is 5 minutes. For premium and dedicated plans, it can be extended up to 60 minutes. Explain the concept of durable entities and durable functions. Durable entities are a stateful compute option in durable functions. They represent durable, virtual instances of an entity with its own state and methods. This allows you to build scalable, stateful applications in a serverless environment. How can you monitor and troubleshoot Azure Functions? Azure Functions can be monitored using Azure Application Insights or Azure Monitor. You can view logs, performance metrics, and errors in the Azure portal. For troubleshooting, you can use tools like Visual Studio Debugger, remote debugging, and exception handling in code. What are function proxies in Azure Functions? Function proxies allow you to define custom routing rules and transformations for HTTP requests and responses. They are useful for scenarios like URL rewriting, header modification, and API versioning. How can you implement durable timers and durable functions? Durable timers can be implemented using the createTimer method in a durable orchestrator function. This method allows you to schedule timers for delays or timeouts within an orchestration. What is the role of the Azure Functions runtime? The Azure Functions runtime is responsible for managing the lifecycle of function instances, including triggering, execution, and scaling. It abstracts the underlying infrastructure, allowing developers to focus on code without worrying about server management. Explain the differences between Azure Functions and Azure Logic Apps. Azure Functions, code-centric, event-driven, and serverless for custom business logic. Azure Logic Apps, workflow automation platform with a visual designer for orchestrating actions and services. What is the maximum execution timeout for a durable function orchestrator? The maximum execution timeout for a durable function orchestrator is 1 year. This allows you to create long-running, stateful workflows. How can you handle state persistence in durable functions? Durable functions automatically handle state persistence for you. The state is stored in durable storage, example, Azure Storage or Cosmos DB, and can be easily accessed within orchestrations and entities. What are the retry mechanisms available for durable functions orchestrations? Durable functions provides built-in retry mechanisms. Retry options. You can configure retry policies with options like max retry count and first retry interval. Transient fault handling. Durable functions automatically retries on transient errors like network issues. Explain the use case for the Azure Functions Premium Plan. The Azure Functions Premium Plan is designed for high-performance, mission-critical workloads. It offers features like unlimited execution duration, VNet integration, and guaranteed compute resources. Use it for applications with strict performance and security requirements. How can you trigger a function based on changes to an Azure Queue Storage message? You can use the Azure Queue Storage trigger. When a new message arrives in the specified queue, it automatically triggers the associated function. What are the benefits of using durable functions for stateful workflows? Simplified state management. Durable functions abstract away the complexities of state management, making it easier to build and maintain stateful workflows. Scalability. Durable functions can scale out to handle a large number of parallel stateful workflows. Reliable execution. Durable functions ensure reliable execution of stateful workflows even in the event of failures. Can you explain the concept of warm-up and cool-down in Azure Functions? Warm-up. Azure Functions allows you to configure warm-up scripts that run before your function app is initialized, ensuring that it's ready to handle incoming requests. Cooldown settings specify how long the app should wait before scaling in, reducing the number of instances after a period of high load. How can you secure sensitive information like connection strings in Azure Functions? Use Azure Key Vault to store and retrieve secrets securely. Configure managed identity for your function app to access Key Vault without storing credentials in code or configuration files. Explain how to implement a custom binding in Azure Functions. To implement a custom binding, you need to create a custom binding extension by defining a binding provider and a binding. This allows you to extend Azure Functions to work with new data sources or services. What are the benefits of using Azure Functions for microservices architecture? Serverless architecture reduces infrastructure management overhead. Event-driven nature makes it suitable for handling asynchronous communication between microservices. Easy integration with Azure services like Azure Service Bus and Azure Event Hubs. What is the role of Azure Functions proxies and why would you use them? Azure Functions proxies allow you to create custom API endpoints and control the routing of requests to different function apps or services. They are useful for building APIs, handling URL redirection, and transforming request/response data. Explain the concept of dependency injection in Azure Functions. Dependency injection in Azure Functions allows you to inject services and dependencies into your function code, promoting modularity and testability. It can be achieved using libraries like Azure Functions Dependency Injection or custom implementations. How can you manage and monitor the consumption of Azure Functions to control costs effectively? Use Azure Monitor and Application Insights to monitor execution and diagnose issues. Set up alerts to proactively respond to scaling or performance problems. Configure auto-scaling rules to optimize resource utilization. Implement rate limiting and quotas to control excessive usage. What are the differences between Azure Functions and Azure Web Jobs? Azure Functions is designed for serverless, event-driven computing, while Azure Web Jobs are designed for continuous and scheduled background processing. Azure Functions are more suitable for lightweight, single-purpose tasks, while Web Jobs are better for complex, long-running tasks. How can you implement retries and dead letter handling in Azure Functions that process messages from Azure Service Bus? You can implement retries and dead letter handling in Azure Functions as follows. Use the max delivery count property in Azure Service Bus to configure maximum delivery attempts. Implement retry logic within your function using try-catch blocks and custom code. Forward failed messages to a dead letter queue for manual inspection. Explain the concept of function triggers and bindings extensibility in Azure Functions. Function triggers and bindings extensibility allows you to create custom triggers and bindings for Azure Functions. This enables integration with custom data sources and events not supported out of the box, extending the capabilities of Azure Functions. What is Azure Functions Premium Plus? Azure Functions Premium Plus is a higher tier of the Premium plan, offering enhanced performance, scaling, and support for ultra-low latency scenarios. It is suitable for applications with strict real-time processing requirements. How can you handle long-running asynchronous tasks in Azure Functions? Use durable functions to orchestrate long-running workflows efficiently. Implement polling mechanisms or webhook callbacks for asynchronous tasks. Leverage queues to manage and track the progress of long-running tasks. Can you explain the concept of function proxies and how they relate to Azure Functions? Function proxies allow you to create custom API endpoints and route requests to different Azure functions or external services. They provide URL rewriting, request/response transformation, and security features. Function proxies are often used to create API gateways for Azure Functions. What are the advantages of using Azure Functions in a multi-cloud or hybrid cloud environment? Azure Functions can be integrated with other Azure services, making it easier to build hybrid solutions. They are platform agnostic, which means you can run them on various cloud providers or on-premises using Azure Stack. Event-driven architecture enables seamless communication between on-premises and cloud components. How can you manage and monitor Azure functions in a production environment? Use Azure Application Insights for end-to-end monitoring, logging, and diagnostics. Configure alerts and notifications for key performance indicators. Set up Application Insights Profiler to analyze function app performance. What is the purpose of function apps in Azure Functions? Function apps provide a logical grouping for Azure Functions and allow you to manage multiple functions as a single unit. They are used to organize and deploy related functions together. Can you explain the differences between Azure Functions and AWS Lambda? Azure Functions, Microsoft Azure Serverless Compute Service. AWS Lambda, Amazon Web Services Serverless Compute Service. Both provide similar functionality, but differences exist in pricing, language support, and integrations with their respective cloud ecosystems. How can you handle and retry transient errors in Azure Functions that interact with external services? Implement retry logic with exponential backoff for handling transient errors. Leverage circuit breaker patterns to prevent repeated retries in case of prolonged failures. Use appropriate exception handling mechanisms and log errors for analysis. What are the limitations of Azure Functions and how can you work around them? Some limitations include execution timeout, maximum memory, and maximum payload size. Workarounds may involve breaking large tasks into smaller functions, optimizing code, and considering premium or dedicated plans for increased resources. Explain how you can implement security best practices for Azure Functions. Use Azure AD for authentication and authorization of HTTP triggers. Employ managed identity for secure access to Azure resources. Implement role-based access control, RBC, for fine-grained permissions. Regularly update and patch dependencies to address security vulnerabilities. What is the Azure Functions Premium Plan's advantage over the consumption plan for mission-critical applications? The Premium Plan provides dedicated compute resources, unlimited execution duration, VNet integration. How can you handle secrets and sensitive data, such as API keys in Azure Functions securely? Store secrets in Azure Key Vault and access them using managed identity. Use Azure Key Vault references in application settings for seamless integration. Avoid hard-coding secrets in code or configuration files. What is the relationship between Azure Functions and Azure Logic Apps? Azure Functions can be used within Azure Logic Apps as custom actions, allowing you to execute custom code in response to events in your Logic App workflow. This provides flexibility in building workflows with serverless compute capabilities. Explain how you can implement versioning for Azure Functions APIs. Use URL versioning by including version information in the URL path. Employ HTTP headers like accept or API version to specify the version. Maintain separate function apps or proxies for different versions if necessary. What is the difference between a function and a function app in Azure Functions? A function is a single unit of code that performs a specific task. A function app is a collection of one or more related functions, configurations, and resources that are deployed together. How can you ensure high availability and fault tolerance for Azure Functions? Deploy Azure Functions in multiple regions for geographic redundancy. Use Azure Traffic Manager for DNS-based load balancing. Implement retry and circuit breaker patterns in your code to handle failures gracefully. What are the key components of an Azure Functions application? An Azure Functions application consists of functions code, triggers and bindings, event sources and data connections, function app settings, configuration, external resources like databases, queues, and storage accounts. Explain how to handle secrets and connection strings securely in Azure Functions. Store secrets and connection strings in Azure Key Vault. Use Managed Identity to access Azure Key Vault secrets. Reference secret values from Key Vault in your function app settings. What is the difference between durable and stateless Azure functions? Durable functions maintain state and orchestration in long-running workflows. Stateless functions are stateless and typically handle short-lived, stateless tasks. How can you implement authentication and authorization for HTTP-triggered Azure functions? Use Azure Active Directory, Azure AD, authentication for securing HTTP triggers. Implement custom authentication middleware if needed. Leverage Azure Functions proxies for API security and routing. Explain the difference between synchronous and asynchronous Azure functions. Synchronous functions execute in response to a trigger and return a response immediately. Asynchronous functions can start a task that runs independently and doesn't block the main execution. What is an Azure Functions Application Insights integration and why is it useful? Azure Functions can be integrated with Application Insights to collect telemetry data, monitor performance, and troubleshoot issues in real time. It provides deep insights into the behavior and health of your Functions application. How can you secure Azure Functions using Azure Active Directory AAD? Configure AAD authentication for your function app. Define app roles and permissions in AAD. Use AAD tokens to authorize users and control access to functions. Can you explain how to implement custom error handling and logging in Azure Functions? Use try-catch blocks in your code to catch exceptions and log errors. Configure Azure Application Insights or other logging providers for detailed error tracking. Utilize structured logging to capture context and diagnostic information. What are the advantages of using Azure Functions for real-time processing of data streams? Azure Functions can be triggered by Azure Stream Analytics, Azure Event Hubs, or IT Hub events for real-time data processing. They provide a serverless and scalable way to analyze and react to streaming data. How can you configure custom domain names for Azure Functions? Configure custom domain names for your function app using Azure Functions proxies or Azure Front Door. Associate the custom domain with the function app's public IP address. What are the differences between Azure Functions and Azure Logic apps in terms of workflow automation? Azure Functions are code-centric and allow for more custom, fine-grained logic. Azure Logic apps provide a visual workflow designer and are better suited for business process automation. Explain how you can implement retry policies for Azure Functions triggered by external services. Utilize Azure Functions built-in retry policies and specify retry options in function bindings. Implement custom retry logic within your function code using exponential backoff or other strategies. What is the purpose of deployment slots in Azure Functions and how can they be used effectively? Deployment slots allow you to stage and test function app changes before deploying them to production. They can be used for A/B testing, blue-green deployments, and rollback scenarios without affecting the live production environment. How can you implement input and output bindings for Azure Functions in Python? Input and output bindings in Python are specified in the function.json file. You can use decorators like @blob_input and @blob_output for blob bindings and similar decorators for other bindings. Explain how you can trigger Azure Functions using Azure Logic apps. Azure Logic apps can use the Azure Functions connector to trigger functions. You can specify the function name, method, and payload to trigger a specific function when a Logic app workflow runs. What are durable entities and how can they be used in durable functions? Durable entities are a stateful and scalable programming model within durable functions. They represent stateful objects that can be accessed and manipulated by multiple functions, allowing for complex coordination patterns. How can you implement unit testing for Azure Functions code? Use testing frameworks like XUnit or PyDis for Python to write unit tests. Mock dependencies or use test environments to isolate the function being tested. Verify the expected behavior of your functions by testing different input scenarios. Explain how to configure custom authorization for Azure Functions HTTP triggers. Implement custom authentication middleware to validate authorization tokens or headers. Use Azure Functions proxies for API gateway features and custom authorization logic. How can you secure data at rest and in transit for Azure Functions and associated resources? Use Azure Storage Service encryption to secure data at rest. Utilize HTTPS for data in transit and configure SSL certificates if needed. Implement Azure Private Link to keep resources on a private network. What is the maximum execution timeout for durable functions orchestrations and entities? Durable functions orchestrations can run for up to 1 year. Durable entities don't have a timeout limit since they represent stateful objects. Explain the concept of Azure Functions proxies and how they help in API management. Azure Functions proxies allow you to create API gateways by defining custom routing rules, transformations, and security settings. They are useful for consolidating multiple functions or APIs under a single endpoint, handling versioning, and applying custom logic. How can you achieve data consistency in Azure Functions when interacting with multiple Azure services? Use transactions supported by Azure Storage or Cosmos DB when dealing with data that requires strong consistency. Implement idempotent operations and retries for eventual consistency. What is the purpose of host.json in Azure Functions, and how can you use it to configure host-level settings? Host.json is a configuration file used to specify host-level settings for a function app. You can configure settings like function timeout, logging, and default values for triggers and bindings in host.json. How can you monitor and trace function execution for debugging and troubleshooting? Utilize Application Insights or Azure Monitor to collect telemetry data. Implement structured logging and custom logging providers to capture relevant information. Use Visual Studio or VS Code extensions for local debugging. Explain how Azure Functions can be integrated with Azure Event Grid. Azure Functions can be triggered by events published to Azure Event Grid topics. This integration allows you to react to a wide range of events from Azure services and custom sources. How can you implement rate limiting for Azure Functions to prevent abuse or overuse of resources? Use Azure API Management for comprehensive rate limiting, throttling, and API governance. Implement custom rate limiting logic within your functions using counters or timers. What are the benefits of using Azure Functions in a microservices architecture? Azure Functions are well suited for implementing microservices due to their event-driven, scalable nature. They can handle individual microservices tasks, such as data processing, authentication, and background processing. How can you handle long-running processes that require user interaction in Azure Functions? Use durable functions to orchestrate long-running processes that involve user interaction. Implement user-friendly notifications like email or mobile push notifications to guide users through the process. What are the best practices for securing Azure Functions against common web application vulnerabilities, such as SQL injection and cross-site scripting (XSS)? Use input validation and parameterized queries to prevent SQL injection. Sanitize and validate user input to mitigate cross-site scripting (XSS) vulnerabilities. Implement Content Security Policy (CSP) headers to control resource loading. Explain how you can achieve idempotence in Azure Functions and why it's important. Idempotence ensures that performing an operation multiple times has the same result as performing it once. To achieve idempotence in Azure Functions, design your functions to handle duplicate requests gracefully, such as by using unique identifiers or checking the current state before executing. How can you ensure proper error handling and retry mechanisms for Azure Functions that interact with external APIs? Implement proper exception handling to catch errors and provide informative error messages. Configure retry policies for HTTP requests using libraries like Poly. Use Azure Functions durable timers for delayed retries. Explain the concept of fan-out/fan-in patterns in durable functions and give an example use case. Fan-out/fan-in is a pattern where multiple tasks are executed in parallel, fan-out, and their results are combined or aggregated, fan-in. Example, in an e-commerce system, you may fan out to multiple inventory check functions to verify product availability and then fan in to calculate the total available quantity. How can you optimize the cold start performance of Azure Functions? Use the Azure Functions Premium plan to reduce cold start times. Enable Always On in the App Service plan settings. Implement singleton patterns to reuse resources across invocations where applicable. Explain the concept of dependency injection and its advantages in Azure Functions. Dependency injection is a design pattern that allows you to inject dependencies, example, services, configurations, into your functions rather than hard coding them. Advantages include improved testability, modularity, and flexibility in changing dependencies without modifying the code. How can you implement custom monitoring and telemetry in Azure Functions using application insights or other logging tools? Instrument your functions with custom telemetry events using Application Insights SDK or other logging libraries. Log key application events, metrics, and context information. Use telemetry data to gain insights into the behavior and performance of your functions. What is the purpose of cross-origin resource sharing CORS, and how can you configure it for Azure Functions with HTTP triggers? CORS is a security feature that controls which web domains can make requests to your API. To configure CORS for Azure Functions, you can specify allowed origins, methods, and headers in the function app settings or by using Azure Functions proxies. Explain how to handle long-running, stateful processes in Azure Functions without using durable functions. Implement a design pattern like polling or saga to manage state and coordination between functions. Use external storage, example, Azure Storage, Cosmos DB, to persist and share state across function invocations. What are the key differences between Azure Functions and Azure App Service for hosting web applications? Azure Functions are designed for serverless, event-driven functions, while Azure App Service is designed for hosting full web applications. Functions are more suited for microservices, background processing, and single-purpose tasks, whereas App Service is for hosting entire web apps and APIs. How can you handle secrets and configuration settings in Azure Functions that differ between development, staging, and production environments? Use environment-specific configurations and settings in your Azure Function app settings. Leverage Azure Key Vault to store sensitive secrets and access them based on the environment. Explain how you can implement asynchronous communication between Azure Functions. Use Azure Storage Queues or Service Bus Queues/topics to facilitate asynchronous communication between functions. Functions can enqueue messages to a queue or subscribe to messages in a topic, allowing for decoupled and asynchronous processing. What are the considerations for managing long-term state in Azure Functions, especially when dealing with stateful workflows that span multiple days or weeks? Durable Functions is the preferred option for managing long-term state, as it provides built-in state management and orchestration capabilities. For workflows that exceed Durable Functions' 1-year timeout limit, consider breaking them into smaller, shorter orchestrations or using external state management solutions like databases. Explain the advantages of using Azure Functions with Azure Kubernetes Service (AKS) in a containerized environment. Azure Functions for Containers allows you to run functions within Docker containers. This enables the use of custom dependencies, libraries, and runtime versions. You can leverage Azure Kubernetes Service (AKS) for scaling, orchestration, and managing containers. How can you ensure data consistency when multiple Azure functions need to update the same resource simultaneously? Use distributed locking mechanisms like Azure Blob Leases or Azure Redis Cache to ensure exclusive access to shared resources. Implement optimistic concurrency control to detect and handle conflicts when multiple functions update the same resource. What is the purpose of an Azure Functions application settings file, local.settings.json, in local development, and how does it differ from production settings? Local.settings.json is used for configuring settings in the local development environment. It typically contains connection strings, secrets, and other environment-specific configurations. In production, these settings are stored in Azure Function App Settings. How can you automate the deployment of Azure Functions using infrastructure as code, IAC, or DevOps practices? Use Azure Resource Manager, ARM, templates, or Terraform to define and deploy the Azure Function infrastructure. Implement continuous integration / continuous deployment, CI/CD, pipelines in Azure DevOps, GitHub Actions, or other CI/CD tools. Explain how you can set up testing and load testing for Azure Functions to ensure they meet performance and reliability requirements. Use load testing tools like Apache JMeter or Azure DevOps load testing to simulate high loads and identify performance bottlenecks. Implement unit testing, integration testing, and end-to-end testing for function logic. What are the advantages and considerations of using Azure Functions for event-driven serverless computing over traditional server-based architectures? Advantages include reduced infrastructure management, cost savings, automatic scaling, and a pay-as-you-go pricing model. Considerations include cold start times, execution duration limits, and potential challenges with stateful workflows. Can you explain the concept of fan-in/fan-out patterns in durable functions and provide an example use case? Fan-in/fan-out is a pattern where multiple tasks are executed in parallel, fan-out, and their results are combined or aggregated, fan-in. Example, in a data processing pipeline, you may fan out to multiple data processors to parallelize work, and then fan in to consolidate results. Explain the concept of distributed tracing and how it can be implemented in Azure Functions for monitoring and troubleshooting. Distributed tracing is a technique used to track the flow of requests across different services and components in a distributed system. To implement distributed tracing in Azure Functions, you can use tools like Application Insights or OpenTelemetry to instrument your functions and gather trace data. This data allows you to visualize the entire request flow and identify performance bottlenecks or errors. Explain the concept of distributed tracing and how it can be implemented in Azure Functions for monitoring and troubleshooting. Distributed tracing is a technique used to track the flow of requests across different services and components in a distributed system. To implement distributed tracing in Azure Functions, you can use tools like Application Insights or OpenTelemetry to instrument your functions and gather trace data. This data allows you to visualize the entire request flow and identify performance bottlenecks or errors. What are the benefits and use cases of Azure Functions Premium Plus plan compared to the standard Premium plan? The Azure Functions Premium Plus plan offers additional features such as enhanced performance, scaling capabilities, and ultra-low latency guarantees. Use cases include real-time processing of financial transactions, IT data processing with sub-second response times, and applications requiring extremely low latency. Explain how you can implement back-off and retry strategies for Azure Functions to handle transient failures more effectively. A back-off and retry strategy involves progressively increasing the delay between retry attempts to prevent overloading a failing service. In Azure Functions, you can implement this strategy by using libraries like Poly or custom code to introduce exponential back-off delays between retries. What are global filters in Azure Functions and how can they be used to perform cross-cutting concerns like authentication and logging? Global filters in Azure Functions are reusable pieces of code that can intercept and modify the execution of functions before or after they run. They are useful for implementing cross-cutting concerns like authentication, logging, or custom request/response handling. Filters can be configured globally for all functions in a function app. Explain the concept of serverless databases and how they can be used in conjunction with Azure Functions. Serverless databases refer to databases that automatically scale resources based on demand, similar to the serverless model. Azure Cosmos DB's serverless mode is an example where you pay only for the request units you consume, making it suitable for use with Azure Functions to build cost-efficient, highly scalable applications. What are binding expressions in Azure Functions and how can they be used to dynamically configure bindings at runtime? Binding expressions allow you to define binding configurations dynamically at runtime based on the input or output of a function. They are particularly useful when you need to configure bindings based on the content of a message, request, or external condition. How can you implement secure, role-based access control, RBC, for Azure Functions to restrict functions to authorized users or groups? Implement RBC by using Azure Active Directory, Azure AD, and Azure Functions Managed Identity. Assign roles and permissions in Azure AD to control access to function apps. Use Azure AD tokens to authorize requests to your functions, allowing only authorized users or groups to invoke them. Explain the advantages of using Azure Functions Premium Plan's VNet integration feature and how it can be used to securely access resources in a virtual network. VNet integration in the Azure Functions Premium Plan allows functions to securely access resources in an Azure virtual network. This feature is useful for accessing databases, internal APIs, or other resources that are hosted within the VNet and not exposed to the public internet. What is Cross-Origin Resource Sharing (CORS), and how can you configure CORS policies for Azure Functions with HTTP triggers to allow or restrict cross-origin requests? CORS is a security feature that controls which web domains are permitted to make requests to your API or web application. In Azure Functions, you can configure CORS policies in the function app settings to specify allowed origins, methods, headers, and expose custom headers as needed. This helps control cross-origin access. Explain how Azure Functions can be used for event sourcing and CQRS, command query responsibility segregation, patterns in microservices architecture. Azure Functions can be used to handle commands, example, writes, and generate events in response. These events can be processed by separate functions as queries, example, reads, to generate views or projections of the data. This enables a scalable and decoupled approach to event-driven microservices architecture. What is the Durable Entity Proxy, and how can it be used in durable functions to interact with durable entities? The Durable Entity Proxy is a client-side object that allows you to interact with durable entities in a type-safe manner. It abstracts the communication with the underlying entity, making it easier to invoke entity methods and manage state. How can you ensure data consistency when using durable functions to orchestrate long-running, distributed workflows with multiple function invocations? You can use the event sourcing pattern to maintain a reliable log of events that capture all changes to the state. By replaying these events, you can reconstruct the state and achieve data consistency even in complex distributed scenarios. How can you implement event-driven Saga orchestrations using durable functions to coordinate and manage distributed transactions across multiple services? You can use durable functions to create Saga orchestrations that coordinate and manage distributed transactions. Each step of the Saga corresponds to a function invocation that performs a specific action, and compensating actions can be defined to handle failures and rollbacks. Explain the purpose of binding expressions in Azure Functions and how they differ from regular binding configurations. Binding expressions allow you to dynamically configure binding parameters based on runtime values. This is different from regular binding configurations, which are typically defined statically at design time. Binding expressions enable more flexible and dynamic behavior. What are the benefits of using Azure Functions proxies for API management, and how do they differ from Azure API Management Service? Azure Functions proxies provide lightweight API gateway capabilities for routing, request/response transformation, and security. Azure API Management is a comprehensive API management service that offers more advanced features like analytics, rate limiting, and developer portal. How can you implement idempotency in Azure Functions to ensure that the same operation can be safely executed multiple times without causing unintended side effects? You can use unique request identifiers, example, request IDs or transaction IDs, to track and prevent duplicate operations. Before executing an operation, check whether it has already been processed with the same identifier, and if so, return the same result without executing the operation again. Explain how Azure Functions can be integrated with Azure Service Bus for building event-driven, asynchronous messaging systems. Azure Functions can use Service Bus triggers to automatically respond to messages in a Service Bus queue or topic. This integration allows you to create highly scalable, loosely coupled, and event-driven systems for processing messages, events, or commands. What are the key considerations and best practices for scaling Azure Functions to handle a large number of concurrent requests and maintain high performance? Optimize code for efficiency, minimize dependencies, and use async/await patterns. Use Azure Functions Premium Plan for dedicated resources and unlimited execution duration. Implement load testing, monitor performance metrics, and adjust instance counts accordingly. How can you implement dead letter handling in Azure Functions when processing messages from queues or topics to deal with messages that cannot be processed successfully? Configure a separate dead letter queue (DLQ) or dead letter topic (DLT) where unprocessable messages are sent. Implement a function to process messages from the DLQ/DLT, log details, and take appropriate action, example, alerting, manual inspection. What are the key benefits of using Azure Functions with durable entities for building stateful serverless applications, and how do they compare to traditional stateful services? Azure Durable Entities allow you to build stateful serverless applications with ease, offering automatic state management and distributed concurrency control. Unlike traditional stateful services, durable entities provide seamless scaling and simplified state management without the complexity of managing infrastructure. Explain the concept of aggregator functions in Azure Durable Functions and how they can be used to collect and process data from multiple parallel function executions. Aggregator functions are used to collect and process data from multiple parallel executions of a function. They can be used to aggregate, summarize, or calculate values from individual function results, such as calculating totals or averages from parallel processing. How can you implement periodic, scheduled tasks or background jobs in Azure Functions, and what are the considerations for scheduling accuracy and reliability? Use timer-triggered functions to implement periodic tasks or background jobs. Ensure that your function app is set to always on to guarantee that timers trigger accurately. Consider the execution frequency and time zone settings for accurate scheduling. Explain the concept of poison messages in the context of Azure Functions and how they can be handled to prevent message processing errors. Poison messages are messages that repeatedly fail to be processed by a function and can potentially block further message processing. To handle poison messages, you can implement mechanisms such as moving them to a dead letter queue (DLQ), setting a maximum retry count, or applying custom error handling logic. What are stateful entities in durable functions, and how can they be used to maintain stateful data and business logic across multiple function invocations? Stateful entities in durable functions are used to maintain stateful data and business logic that can be accessed and modified across multiple function invocations. They provide a structured way to model stateful components in your application, such as user sessions, shopping carts, or workflow instances. Explain the role of singleton orchestrators in durable functions and how they can be used to control concurrency and ensure serial execution of tasks. Singleton orchestrators are orchestrations that act as singletons, meaning that only one instance of the orchestration can run at a time. They are used to control concurrency, ensure serial execution of tasks, and avoid race conditions when multiple instances of the same orchestration might run concurrently. How can you implement human interaction steps and durable functions to handle scenarios where human approval or input is required within long-running workflows? Use durable human interaction patterns to introduce human approval or input steps within long-running workflows. Implement external systems or user interfaces to capture and process human input, then resume the orchestration accordingly. What are fan-out/fan-in patterns, and how can they be implemented in durable functions to parallelize and aggregate tasks or data processing? Fan-out/fan-in patterns involve parallelizing tasks or data processing by distributing work to multiple instances and then aggregating the results. Durable functions provide built-in support for implementing these patterns using durable orchestrations and activities. Explain the concept of sub-orchestrations in durable functions and how they can be used to encapsulate and reuse complex logic within orchestrations. Sub-orchestrations are orchestrations that can be called from within other orchestrations, encapsulating complex logic. They promote code reuse, modularity, and maintainability by allowing you to separate and encapsulate specific workflow steps. How can you implement custom status reporting for long-running durable functions orchestrations to track progress, errors, or custom states effectively? Implement custom status reporting by using external storage, example, Azure Table Storage or Cosmos DB, to store and update orchestration status information. Design the orchestration to periodically report its progress or custom states to the external storage. What is the role of sub-orchestration chaining in durable functions, and how can it be used to orchestrate complex workflows efficiently? Sub-orchestration chaining is a pattern in durable functions where one sub-orchestration is used to start and manage the execution of multiple child sub-orchestrations. It is useful for orchestrating complex workflows that involve multiple sub-orchestrations with dependencies and coordination requirements. Explain how external events can be used in durable functions to trigger orchestrations and respond to events generated by external systems. External events are events generated by external systems or processes that can trigger orchestrations in durable functions. You can use external events to initiate long-running workflows in response to real-time events, such as sensor data, customer interactions, or IT device signals. How can you implement aggregator orchestrations in durable functions to collect and aggregate data from multiple parallel orchestrations or entities? Aggregator orchestrations are orchestrations that coordinate the execution of multiple parallel child orchestrations or entities. They collect and aggregate data or results from these child instances to produce a consolidated output. Explain the concept of fan-out/scale-in patterns in durable functions and provide an example use case for optimizing resource consumption. Fan-out/scale-in is a pattern that involves rapidly scaling out, parallel execution, and then scaling in, consolidating resources as needed. Example use case: in a periodic data processing workflow, rapidly scale out instances to handle incoming data spikes and then scale in to reduce resource consumption during quiet periods. What is the purpose of orchestration bindings in durable functions, and how can they be used to interact with external systems and services? Orchestration bindings in durable functions allow you to interact with external systems and services directly from an orchestration. They provide a convenient way to perform actions like sending emails, making HTTP requests, or interacting with databases within an orchestration. How can you implement external events orchestrations in durable functions to wait for external events to occur before proceeding with the workflow? External events orchestrations are designed to wait for external events, such as user actions or external system events, before progressing with the workflow. You can use this pattern to create responsive workflows that react to real-world events. Explain the role of human interaction orchestrations in durable functions and how they can be used to incorporate human decisions and approvals into workflows. Human interaction orchestrations in durable functions are used to model workflows that require human decisions, approvals, or interventions. They interact with external systems or interfaces to capture and process human input, allowing workflows to adapt based on human actions. How can you ensure exactly once processing semantics in durable functions to guarantee that a message or operation is processed only once, even in the presence of failures? Achieving exactly once processing can be challenging but is possible through techniques like idempotency, deduplication, and maintaining a reliable message processing log. Ensure that idempotent operations can be retried without unintended side effects, and use message deduplication mechanisms where available. What are entity clients in durable functions, and how can they be used to interact with stateful entities efficiently? Entity clients in durable functions are client-side objects that allow you to interact with stateful entities efficiently and in a type-safe manner. They abstract the communication with the entity and provide a convenient API for invoking methods and accessing state. Explain how external dependencies can be managed in durable functions, such as ensuring that external systems are available and responsive during orchestrations. External dependencies in durable functions, such as external APIs or services, should be handled with proper error handling and retries. Implement timeout mechanisms in circuit breaker patterns to ensure that orchestrations gracefully handle external system failures and unavailability. What is the purpose of singleton pattern in durable functions, and how can it be used to ensure that only one instance of a particular orchestrator or entity runs at a time? The singleton pattern in durable functions is used to ensure that only one instance of a particular orchestrator or entity can run concurrently. It's helpful in scenarios where you want to prevent parallel execution of certain orchestrations or entity methods to maintain data consistency. Explain how you can implement dynamic input and output bindings in Azure Functions to handle situations where binding configurations need to be determined at runtime. Dynamic input and output bindings allow you to specify binding configurations at runtime rather than statically defining them. You can achieve this by using binding expressions and configuring bindings programmatically based on runtime conditions. What is the purpose of instance tags in durable functions, and how can they be used to add custom metadata and context to orchestrations and entities? Instance tags in durable functions allow you to associate custom metadata and context with orchestrations and entities. They are useful for adding additional information that can be used for tracking, auditing, and querying orchestrations and entities. How can you implement event-driven versioning in durable functions to handle changes in the structure or behavior of long-running orchestrations over time without breaking existing instances? Event-driven versioning involves using events to signal changes in the behavior or structure of long-running orchestrations. By introducing version-specific event handlers and state migration logic, you can ensure that existing orchestration instances continue to function correctly when changes occur. Explain how to implement multi-step compensation and durable functions to handle complex compensation logic when a long-running workflow needs to be rolled back or corrected. Multi-step compensation involves defining a series of compensating actions that can reverse or correct the effects of previous steps in a workflow. Implement compensating orchestrations or activities to execute these actions when necessary to undo or correct the workflow's progress. How can you design fan-in orchestrations and durable functions to aggregate results from multiple parallel child orchestrations while ensuring that all child orchestrations have completed? Fan-in orchestrations in durable functions involve starting multiple parallel child orchestrations and waiting for all of them to complete. You can use constructs like the task.whenAll pattern to ensure that the parent orchestration waits for the completion of all child orchestrations before proceeding to aggregation. What are escalation orchestrations and durable functions, and how can they be used to handle scenarios where an issue requires human intervention or complex resolution? Escalation orchestrations are designed to handle situations where an issue or exception cannot be resolved automatically and requires human intervention. They can trigger notifications, alerts, or workflows to escalate the issue to the appropriate personnel for resolution. How can you implement scheduled retries and durable functions to retry specific steps or actions within an orchestration at predetermined intervals until successful completion? You can implement scheduled retries by combining timers and retry logic within the orchestration. Use timers to schedule retries at specific intervals in retry mechanisms, example exponential backoff, to control the retry behavior. Explain how you can achieve throttling in durable functions to limit the rate of execution or resource consumption, especially when interacting with external systems or APIs. Throttling can be implemented by controlling the rate of orchestration or activity execution using mechanisms such as semaphores or rate limiters. Ensure that you respect external system limits and constraints to avoid overloading them. What is the role of instance termination in durable functions, and how can it be used to cancel or terminate orchestrations or entities gracefully? Instance termination in durable functions allows you to cancel or terminate orchestrations or entities gracefully. You can implement custom logic to handle cleanup, resource release, or notification before terminating instances. What is fan-out/fan-in with aggregation in durable functions, and how can it be used to parallelize tasks, collect results, and perform aggregation in complex workflows? Fan-out/fan-in with aggregation is a pattern that involves parallelizing tasks using fan-out, collecting the results of these tasks using fan-in, and performing aggregation or summary operations on the collected results. It's beneficial for scenarios where you need to process data in parallel, such as analyzing data from multiple sources and aggregating the results into a single output. Explain the use of durable timers and durable functions and how they can be used to introduce delays or timeouts within orchestrations. Durable timers allow you to introduce time-based delays or timeouts within orchestrations. You can use them for scenarios like retrying an action after a specified delay, implementing timeouts for external operations, or scheduling tasks for the future. How can you implement external event sourcing in durable functions to maintain event-driven state and allow external systems to contribute to the event stream of an orchestration? External event sourcing involves allowing external systems or processes to contribute events to the event stream of a durable functions orchestration. You can implement this pattern by exposing HTTP endpoints or other integration mechanisms for external systems to send events that impact the orchestration state. What are Azure Functions extensions, and how do they extend the functionality of Azure Functions in terms of triggers, bindings, and custom processing logic? Azure Functions extensions are reusable components that extend the functionality of Azure Functions, providing additional triggers, bindings, and custom processing logic. They allow you to integrate with various services, protocols, and data sources beyond the built-in triggers and bindings. Explain how you can implement data streaming in Azure Functions to process large volumes of real-time data from sources like IoT devices or social media streams efficiently. Data streaming in Azure Functions involves processing continuous streams of data in real time. You can use Azure Stream Analytics, Event Hubs, or IT Hub triggers in combination with Azure Functions to consume and process streaming data efficiently. How can you implement infinite loops in durable functions to create long-running background tasks that continuously execute without a fixed endpoint? Infinite loops in durable functions can be achieved by designing orchestrations that loop indefinitely. Use conditional logic and timers to control the flow of the loop, allowing the orchestration to continue executing indefinitely. Explain the concept of durable entities reentrancy and how it can be managed to handle scenarios where an entity invokes an orchestration that, in turn, interacts with the same entity. Durable entities reentrancy occurs when an entity invokes an orchestration that interacts with the same entity, potentially leading to recursion. Careful design and control mechanisms are needed to manage reentrancy and prevent infinite loops or excessive recursion. What are the benefits and use cases of binding providers in Azure Functions, and how can they be used to extend the list of supported bindings? Binding providers allow you to extend the list of supported bindings in Azure Functions by creating custom binding extensions. They are useful for integrating with custom data sources, services, or protocols not covered by built-in bindings, enabling a wide range of use cases. Explain how you can implement circuit breaker patterns in durable functions to handle scenarios where an external system or dependency experiences frequent failures or slowdowns. The circuit breaker pattern involves monitoring the status of an external system or dependency and temporarily blocking further requests if it's in a degraded state. Implement circuit breaker logic within orchestrations or activities to gracefully handle external system issues and prevent excessive retries. What is durable entity proxy polling in durable functions, and how can it be used to efficiently poll entities for changes or events without constantly invoking functions? Durable entity proxy polling allows you to efficiently monitor entities for changes or events without invoking functions continuously. It involves periodically polling entity state or subscribing to events using a proxy, reducing the overhead of constant function invocations. What is durable functions external interaction, and how can it be used to integrate with external systems, services, and workflows to orchestrate complex scenarios? Durable functions external interaction refers to the capability of durable functions to interact seamlessly with external systems, services, and workflows. This integration allows you to build orchestrations that coordinate and manage interactions with external components, making it possible to automate complex end-to-end scenarios. Explain the concept of fan-out/fan-in with dynamic scaling in durable functions and provide an example use case where dynamic scaling of resources is essential. Fan-out/fan-in with dynamic scaling extends the typical fan-out/fan-in pattern by dynamically scaling resources, example, function instances, based on the workload. Example use case: in an e-commerce application, dynamically scale the number of parallel functions handling incoming orders during peak shopping seasons and scale down during off-peak times. How can you implement orchestration callbacks in durable functions to notify external systems or services when a specific milestone or condition is reached within an orchestration? Orchestration callbacks involve sending notifications or invoking external services when certain conditions or milestones are reached within an orchestration. Implement callbacks using external HTTP requests, webhooks, or other integration mechanisms to notify external systems or trigger specific actions. What is durable functions human workflow, and how can it be used to model and automate complex human-centric processes that involve approvals, reviews, and decision-making? Durable functions human workflow refers to the use of durable functions to model and automate workflows that involve human interactions, such as approvals, reviews, and decision-making. It allows you to orchestrate complex processes involving both automated and human tasks seamlessly. Explain how partitioning can be implemented in durable functions to distribute workloads across multiple orchestrations, achieving parallelism and improved scalability. Partitioning in durable functions involves dividing a large workload into smaller partitions that can be processed independently in parallel. Implement orchestrations that process these partitions concurrently, distributing the workload and improving overall performance. What is state preservation in durable functions, and how does it ensure the durability and reliability of long-running orchestrations in the face of transient failures or interruptions? State preservation in durable functions ensures the durability and reliability of long-running orchestrations by persistently storing their execution state. It allows orchestrations to resume from the exact point where they left off, even after transient failures or interruptions, providing fault tolerance and resiliency. How can you implement error handling orchestrations and durable functions to centralize and manage error handling and retries across multiple child orchestrations or activities? Error handling orchestrations are orchestrations dedicated to managing error handling and retries for child orchestrations or activities. They can implement retry policies, error logging, and compensating actions to handle errors gracefully and improve the reliability of workflows. Explain the concept of state replication in durable functions and how it can be used to replicate state across multiple locations or regions for high availability and disaster recovery scenarios. State replication involves replicating the state of durable functions orchestrations or entities across multiple locations or regions for high availability and disaster recovery. It ensures that if one region or location becomes unavailable, the workflow can continue processing from a replicated state in another location. What are the considerations for implementing global orchestration state in durable functions to manage and coordinate state across multiple orchestrations in a distributed environment? Global orchestration state involves managing and coordinating state information that needs to be shared across multiple orchestrations in a distributed environment. Considerations include data consistency, synchronization, and conflict resolution strategies to ensure the correctness of shared state. How can you implement custom durable functions triggers to create custom event-driven triggers that initiate orchestrations or activities based on specific criteria or events? Custom durable functions triggers involve creating custom event sources and triggers that initiate orchestrations or activities when specific events occur. You can develop custom triggers using Azure Functions extensions and the Durable Task Framework to extend the capabilities of durable functions. What are orchestration fan-out and fan-in patterns in durable functions, and how can they be used to manage complex workflows that involve branching and merging execution paths? Orchestration fan-out and fan-in patterns involve branching the execution path into multiple parallel workflows, fan-out, and then merging the results back together, fan-in. They are useful for scenarios where a single orchestration needs to coordinate and aggregate data from multiple parallel execution paths. Explain the concept of durable function chaining and provide an example use case where chaining orchestrations is essential for building complex workflows. Durable function chaining refers to the practice of chaining multiple orchestrations together, where the output of one orchestration becomes the input for the next. Example use case: in a complex order processing system, chaining orchestrations can be used to verify payment, update inventory, and send shipping notifications sequentially. How can you implement cross-function correlation in durable functions to correlate and track the execution of multiple functions involved in a single workflow? Cross-function correlation involves tracking the correlation between different functions within a workflow, ensuring that they are part of the same logical unit of work. You can achieve this by passing a correlation identifier through function parameters or using context objects to link related function executions. Explain the use of proxy orchestration in durable functions and how it can be employed to encapsulate and manage the complexity of long-running workflows and interactions with external systems. Proxy orchestration is an orchestration that encapsulates and manages the complexity of long-running workflows, interactions with external systems, or multi-step processes. It acts as an intermediary, providing a simplified and well-structured interface for invoking and controlling complex workflows. What are scheduled orchestrations in durable functions, and how can they be used to implement scheduled background tasks or recurring workflows with time-based triggers? Scheduled orchestrations in durable functions are orchestrations that start based on a schedule or time-based trigger. They are suitable for implementing recurring background tasks, such as daily reports generation, data cleanup, or periodic maintenance jobs. How can you implement multi-region orchestration failover in durable functions to ensure the high availability of orchestrations and stateful entities across multiple Azure regions? Multi-region orchestration failover involves replicating orchestrations in stateful entities across multiple Azure regions to ensure high availability. It requires careful design of state replication, error handling, and routing to failover regions in case of regional failures. Explain the use of Azure Functions Premium Cold Start and how it differs from the standard cold start behavior in Azure Functions Premium plan. Azure Functions Premium Cold Start is a feature in the Premium plan that significantly reduces cold start times by pre-warming instances based on predicted load. It differs from standard cold start behavior, where instances are created upon demand, potentially resulting in longer response times. How can you implement distributed transactions and durable functions to maintain data consistency across multiple systems or services when orchestrating complex workflows? Distributed transactions and durable functions involve coordinating actions across multiple systems or services within a single transactional context. You can implement distributed transactions using techniques like two-phase commits or compensating transactions to ensure data consistency. What is external event aggregation in durable functions, and how can it be used to aggregate and process events from external sources efficiently within orchestrations? External event aggregation involves efficiently aggregating and processing events from external sources within durable functions orchestrations. It can be used to collect, filter, and act upon external events as they occur, enabling real-time event-driven workflows. Explain the concept of stateful entity snapshot in durable functions and how it can be used to optimize performance and reduce storage costs when working with stateful entities. Stateful entity snapshot refers to the process of capturing a snapshot of a stateful entity's state at a specific point in time. It can be used to optimize performance by reducing the amount of state data loaded and to minimize storage costs by storing periodic snapshots rather than the entire history. What are durable function extensions, and how can they be leveraged to extend the capabilities of durable functions beyond the built-in features? Durable function extensions are custom extensions or modules that can be added to durable functions to extend their capabilities. Developers can create and use extensions to add custom functionality or integrate with external services not natively supported by durable functions. Explain how fan-out/fan-in with dynamic load balancing can be implemented in durable functions to distribute workloads efficiently and optimize resource usage. Fan-out/fan-in with dynamic load balancing is an extension of the fan-out/fan-in pattern that dynamically distributes workloads based on available resources. It ensures that work is evenly balanced among instances, preventing resource bottlenecks. How can you implement custom monitoring and logging in durable functions to gain deeper insights into the execution of orchestrations, entities, and activities? Implementing custom monitoring and logging involves integrating durable functions with monitoring and logging solutions, such as Azure Application Insights or custom logging frameworks. It allows you to capture detailed execution data, troubleshoot issues, and monitor performance effectively. What is durable function subscriptions, and how can it be used to create event-driven architectures where orchestrations are triggered by external events or messages? Durable function subscriptions are event subscriptions that enable orchestrations to be triggered by external events, such as changes in databases, message queue messages, or custom events. They are essential for creating event-driven serverless architectures. Explain the concept of durable function activity batching and how it can be used to optimize performance when invoking activities in bulk. Durable function activity batching involves grouping multiple activity invocations into batches to reduce the overhead of individual calls. It's useful when you need to perform the same activity on multiple items concurrently, such as data processing or parallel tasks. How can you implement distributed locking in durable functions to prevent concurrent execution of specific operations across multiple instances of an orchestration or entity? Distributed locking involves using distributed locks, such as Azure Blob Leases or Redis locks, to synchronize access to critical sections of code within orchestrations or entities. It ensures that only one instance can execute the locked operation at a time, preventing conflicts and data corruption. Explain the concept of versioning strategies in durable functions and how they can be applied to handle changes and updates to existing orchestrations and entities. Versioning strategies in durable functions involve defining how changes to orchestrations or entities are managed over time to ensure compatibility. Strategies may include backward compatibility, migration scripts, or maintaining multiple versions in parallel. What is durable function state transition, and how can it be used to implement state changes and transitions within long-running orchestrations or entities? Durable function state transition refers to the process of transitioning the state of an orchestration or entity during its execution. It is commonly used to model and manage complex workflows with different states and transitions. How can you implement durable function validation and verification to ensure that data processed within orchestrations or entities meet specific criteria or business rules before proceeding? Durable function validation and verification involve implementing checks and validations within orchestrations or entities to ensure the correctness and integrity of data. They help prevent errors and ensure that only valid data is processed further. Explain how event-driven testing can be applied to test durable functions, orchestrations, and entities in isolation by simulating external events and inputs. Event-driven testing involves simulating external events, inputs, and triggers to test orchestrations and entities in isolation. It allows you to verify the behavior and correctness of durable functions components without relying on actual external events or dependencies. What are durable function orchestrator chaining patterns, and how can they be used to design complex workflows with multiple steps and dependencies? Durable function orchestrator chaining patterns refer to the various ways orchestrations can be chained together to create multi-step workflows. These patterns include sequence, parallel, and fan-out/fan-in chaining, allowing you to design complex workflows with precise control over execution flow. Explain how durable function error handling strategies can be implemented to handle exceptions, retries, and compensation logic within orchestrations effectively. Durable function error handling strategies involve implementing robust error handling mechanisms within orchestrations. Strategies may include retry policies, custom exception handling, compensating actions, and logging to ensure the reliability of workflows. What is durable function hybrid orchestration, and how can it be used to combine serverless orchestrations with server-based processing for hybrid cloud scenarios? Durable function hybrid orchestration combines serverless orchestrations with server-based processing to handle hybrid cloud scenarios. It allows you to leverage both serverless and traditional computing resources as needed for optimal performance and scalability. Explain the concept of durable function divergent fan-out and how it can be used to perform parallel processing while dynamically controlling the number of concurrent tasks based on conditions. Durable function divergent fan-out involves performing parallel processing while dynamically adjusting the number of concurrent tasks based on conditions or input data. It helps optimize resource utilization and improve efficiency in scenarios with variable workloads. How can you implement durable function hybrid state management to combine serverless state management capabilities with external state stores for increased flexibility and scalability? Durable function hybrid state management involves using serverless state management for some aspects of the workflow and external state stores, such as databases or cache, for others. It allows you to balance the advantages of serverless state management with the flexibility of external storage. What is durable function smart polling, and how can it be used to optimize polling intervals and reduce unnecessary polling in scenarios with varying event rates? Durable function smart polling involves dynamically adjusting polling intervals based on event rates and activity to reduce unnecessary polling. It helps improve efficiency in scenarios where the frequency of events varies. Explain how durable function state machine patterns can be implemented to model complex state transitions and workflows within orchestrations and entities. Durable function state machine patterns involve modeling complex state transitions and workflows using state machine concepts within orchestrations and entities. They provide a structured approach to managing and tracking states, making it easier to handle intricate scenarios. What are durable function human interaction best practices, and how can they be applied to design user-friendly, responsive workflows that involve human input and approvals? Durable function human interaction best practices include strategies for designing workflows that involve human interactions, such as approvals and reviews. They focus on creating responsive, user-friendly experiences and efficient communication with external systems or users. How can you implement durable function long-term storage to archive or retain orchestration and entity history for compliance, auditing, or historical analysis purposes? Durable function long-term storage involves archiving or retaining orchestration and entity history data for extended periods. It ensures compliance with data retention policies and enables historical analysis and auditing. Explain the concept of durable function global events and how they can be used to trigger orchestrations based on events occurring across multiple regions or environments. Durable function global events refer to events that trigger orchestrations based on occurrences in multiple regions or environments. They enable cross-region coordination and event-driven workflows that respond to global events. Note: if you need question bank PDF, please leave a comment. We will contact and send the PDF.
Hey, if you like the content, please subscribe to my channel. Don't forget to ring the notification bell so you never miss a bite of Azure brilliance.